Good afternoon, students, and welcome to the live session 1 of this NPTEL MOOCs course on membrane technology. I am sure all of you are, those who have registered for this course are watching the videos. We are running module 6, okay. And before I take up your questions and queries, so let us discuss that what you have already learnt by this date. So if you recall, we have initially started discussing that what is membrane, how the history. Then we have discussed the historical developments of membrane, also how we have how the membranes were developed, how the membrane technology has come into force basically, and then we have started discussing what are the materials that are essential for making membrane, right, or manufacturing or producing membranes. So we have discussed about mostly the polymeric materials, their properties, which of the properties are suitable for membrane manufacturing, which are not so. If they are not so, then how we are going to fine tune it, okay, how a membrane can be tailor made. Then we have already also discussed about our ceramic membranes. So certain ceramic, not ceramic membranes, ceramic materials for preparing ceramic membranes, of course. So their properties, okay, we have discussed in detail. Then in the next phase, we have started discussing that how you prepare membranes. Okay, both polymeric membrane as well as we have also discussed about how you are preparing the ceramic membranes. We discussed about composite membranes, and in between we have also discussed that how membranes are being classified. Okay, what are the different types of membrane? What are the different classifications exist? I have given you in detail. So based on the membrane materials, based on operating principles, based on the charge, there are so many things. The mode of operation, correct. So all these things we have discussed in detail. Now next is that how once you prepare the membrane, okay, there are different processes that we have discussed. Okay, once we are done with the membrane preparation, you need to characterize the membrane. Now when I say you characterize the membrane, it is essentially of characterizing the different properties of the membrane. So one of them is the pore size, the very important thing, correct, the membrane pore size. Then pore volume, okay. Then the surface properties, the surface area and all these things, right. So all these things we calculate for different microfiltration membranes, ultrafiltration membrane, and there is a different range of membranes, whether it is a polymeric membrane, whether it is ceramic membrane, whether it is composite membrane. So we need to characterize them. So different characterization techniques we are going to learn. So some of them are microscopic techniques such as the SEM, TEM, AFM. Okay. Then we will be discussing about bubble point method, modified bubble point method, porosimetry method, mercury porosimetry. Okay. Nitrogen adsorption, desorption method. So all this DSC, differential scaling calorimetry method. So all these things we are going to discuss in detail. Once that is done, then we will discuss about this we have not discussed. We will be discussing about the transport in membranes, correct. So how transport inside membrane happens. So that is little more conceptually thermodynamical things. So more thermodynamics aspects are involved into that. The engineers, like especially mechanical and chemical engineers, those who are attending this course, they must have been read about thermodynamics, so they can understand it a little easily. Nevertheless, others also can also understand. I have given the concepts in very clearly, concisely, so that any layman can also understand. In case you have any doubt, you can always ask me. Register your query in the portal, Swayam portal, drop a mail to me. I will be very happy to answer that question. So once we finish up this section, basically your transport in membranes, what we are going to do is that we are going to start one by one membrane processes. So we will be starting with osmosis, followed by reverse osmosis, then microfiltration, ultrafiltration, nanofiltration, pervaporation, membrane distillation, then hybrid processes. Now all these processes we are going to discuss their basic principles, the types of membranes that is being used to prepare this type of membranes, their applications, where they can be applied, okay, with certain applications are given in detail, okay. Then there are different types of hybrid processes also we are going to discuss. How do we combine pervaporation with membrane distillation, or pervaporation with this one here reverse osmosis. So like this, there are so many things are there, so that we are going to discuss. Then we will also discuss about our membrane applications in various fields like desalination, wastewater treatment, then dairy industries, pharma industries, all these things. So all these case studies will be subsequently discussed in respective modules. So once all these things are discussed, we will be discussing about the transport again, how passive transport happens, how active transport happens, all these things we will be discussing. So there are a lot many things coming up in the subsequent modules from the next week onwards. I hope you are really enjoying the course, and if you have any question or query, please drop a message. I will be very happy to answer it right now. Two people watching. Okay, I think since there are no questions coming, I can tell you small things. So a few questions that comes to my mind. Quickly, I'll tell you. Usually being asked or may help the students when they face interviews. Okay. So the first question is that what is the difference between membrane filtration and ordinary filtration? Both are filtration. क्या difference है? What is the difference? Now the pore size. It's all about pore size. The pore size is less than 0.2 micron. If the pore size is less than 0.2 micron, then it's membrane filtration. And if the pore size is higher, then it is ordinary filtration. Sometimes we can call it a coarse filtration. Okay. So another very important thing of characterization is molecular weight cutoff. Okay. How do you determine molecular weight cutoff? MWCO. We have discussed in detail, but some of the important things that comes into mind, I'll just briefly tell you since I don't get any questions here. So why to waste time? Let us discuss something. Okay. Those who are listening to me at least can get a idea about what is MWCO. So let us say if the MWCO molecular weight cutoff is greater than equal to 400 or equal to 400, उसका मतलब क्या है? Then basically the meaning is that the solutes whose molecular weight are greater than 400, all of them will be retained on the surface of this particular membrane whose molecular weight cutoff has been determined to be 400. Okay, so it's a membrane characterization technique. So how do we get it? So membrane experiments will be held with different uncharged solutes of different molecular weights like sucrose, polyvinyl alcohol, polyethylene glycol, dextran. These are being used as solutes to carry out membrane experiments. Now the observed retention, whatever that it is getting retained on the surface of the membrane, okay, that is plotted against the logarithmic of the molecular weight Okay, and you will get a S-shape curve. You remember we have discussed it, observed retention and all these things. So this sharp change corresponds to the molecular weight cutoff. This is the way how you get molecular weight cutoff. Now, if you talk about another question, usually these are the small questions that comes to my mind when people ask in interviews. What is real retention and what is observed retention? Correct. So the real retention represents the membrane solute interactions and defines the selectivity of the membrane. If you recall the equation, so R equals to 1 minus Cp by Cm. So how much solute concentration in permeate stream compared to feed stream, that is determined by the observed retention. So it is R equals to 1 minus Cp by C naught. These are small things. I think we have all discussed, but just I am sharing with you. Then what is osmotic pressure? Okay. So this term we have come across many times during osmosis and reverse osmosis. So it is a colligative property of a solute, correct? And can be realized in presence of only a semi-permeable membrane. If there is a semi-permeable membrane, then only osmotic pressure will come into picture. Certain components will pass through it, certain will not pass through it. Okay. So what is the difference between osmosis and reverse osmosis? So reverse osmosis, as the name says, it is just the ulta reverse of the osmotic process. Now passage of solvent from low concentration, okay, to higher concentration due to the concentration gradient, okay, is osmosis. Now when pressure is applied greater than the osmotic pressure on the reverse side, then the reverse thing will happen. Now that is what is called reverse osmosis. So basically solvent from higher concentration will go to the lower concentration. That's what is called reverse osmosis. As you know, reverse osmosis is one of the most important technology for desalination purposes. If you go to Saudi Arabia, United Arabs, that side in the Gulf countries, when you land, you will see big dumps of reactor type of things. Okay, from the I'm talking about the aerial view. Okay, so those are desalination plants. Hundreds and thousands of desalination plants are there. Whatever water you are going to use it inside the Gulf countries, basically they are all desalinated water. They don't have fresh water. Okay, so slowly water scarcity is increasing in India also. Summer is coming, okay. Go to places like Delhi, Chennai, Hyderabad, Bengaluru, even some other places also. Okay, these are big metro cities, that's why I have named them. Huge water scarcity will come up in few or certain areas of these cities, mega cities. Okay, so the big problem is that the shortage becomes so acute that people do not get potable water for drinking also. So you can imagine a situation wherein somebody sitting in Bangalore do not have access to water for drinking also. What will happen to them? Okay, so I am not telling that everywhere seawater is available, so you pump it, desalinate, and give it to the people. That is not the answer always. That is feasible only when you are located in a coastal district. Okay, suppose you are in, let us say my place, hometown, Balasar in Odisha, which is a coastal district. If you are in Calcutta also, still it is fine, feasible. If you are in Surat, if you are in Bombay, if you are in Trivandrum, so in Vizag, so all these are coastal places. Okay, Barampur. So what I am saying that these places the water can be desalinated easily, and you do not have to pipe them to a different place. Though it is possible, but there is a huge cost involved in that, right? So there are ways to address our water scarcity problems. I am not going to dwell into this particular aspect because that's something different. This course does not deal with that. So we discussed about reverse osmosis, and desalination is one of the most important process that was developed on the RO. This one, what is that is called process. Okay, and you know that now our water purifiers are also this one loaded with our RO technologies, new varieties of so many different types of water purifiers are coming. The household potable water purifiers. Okay. So also there are many questions. If you have something to ask me, you please go ahead and tell me. Okay. Another important thing that comes to my mind is that what is fouling? Okay, and what is the difference between concentration polarization and fouling? So when the membrane process is happening, the solutes are continuously getting deposited on the surface of the membrane. Correct. So that getting deposition of this solute on the surface of the membrane is called concentration polarization. So concentration of the solutes that is getting polarized on the surface of the membrane, that is why that name is concentration polarization. Ab fouling kya hai? So fouling is the subsequent process of this concentration polarization. So your membrane separation process is continuously going on. Okay, so it's a continuous process, right? It can be batch also. So doesn't matter. Okay, so the solutes, more and more number of solutes are getting rejected and getting deposited on the surface of the membrane. So there is a initially there is a monolayer separation deposition, then there is a bilayer deposition, trilayer. It goes on. The layer goes on. Okay. Now what will happen after some time? This particular concentration polarization layer, this one layer will become so rigid, then that will provide a big resistance to the membrane separation. So no more solvent will come out or no more separation will happen. There will be no more permeate. Okay. So now this is due to fouling. Okay. So concentration polarization is the initial phenomena. When membrane becomes when that concentration polarization layer becomes a cake layer or a gel layer, so it provides so much of resistance that tells us about that the membrane is now getting fouled. Now fouling can be of two types: exterior fouling, that is the depositor on the surface of the membrane. Then there can be interior fouling also, that means membrane ke pores ke andar, okay, inside the pores of the membrane. Correct. So the solutes under pressure are getting pushed inside the pores of the membranes. I told you many times in the class, pores are of different shapes and structure. Let us say there is a constriction, something like this. Okay, now the solute is getting deposited on the constricted place. So iska the opening of the mouth or the pore size, which you basically measure from the top side, surface side, is bigger than the solute molecular weight. So the molecular weight, so the solute will pass through and gets deposited on the constricted places because there is a constriction there. It will not get inside to the downstream side. That means that particular pore getting fouled. This is interior fouling. Correct. So this is the difference between concentration polarization and fouling. Okay. So then another question that comes into mind, that what are the most important membrane qualities or should be. So the first very important thing is that membrane should be high selectivity. There should be high selectivity. There should be high permeability also. And then there should be good mechanical and temperature stability or thermal stability. Then finally it should be chemically resistant. Okay. So these are some of the things. Okay, slowly, because as I understand that we are only module 6th is running. Next week onwards, module 7th will start. So we are not into much details. Okay, we are slowly learning. No problem. We have 36 classes. Okay, so another 21 classes left for this particular course. We will be meeting for live session, two more live sessions. So that time we'll discuss more. Okay, and if you have still any question, please go ahead. Okay. नेटवर्किंग की बहुत हो रही है, कोई आवाज ही नहीं. 6 watching now. So there are no questions. Excel file managing. And the question will come here also, no? It will not come. Achha. Only live here, no? In the chat box. मेम्ब्रेन टेक्नोलॉजी कोई क्वेश्चन नहीं किया उस पहले वाला देखिए नहीं है सर नहीं है but other course it was there. वेट करें बंद कर दें बंद कर दीजिए कोई नहीं जस्ट बंद कर दीजिए so students I am signing up. I don't get any more queries. Still in case somebody is joining late or wish to ask me something, you are free to please register your queries in the Swayam portal. I'll be very happy to answer. If you can directly write to me at kmohanty@iitg.ac.in also, and I'll also reply to you. So see you in the next live session that will be in March middle. It will be notified. Okay. So thank you very much.